sedimentary rocks comprise a relatively very small portion of the Earth, they are of significant interest to geologists because they can give us clues to past environments. And in addition, some sedimentary rocks contain fossils, and others contain key natural resources, things like coal and oil. Sedimentary rocks form at or near the surface of the Earth, and they can form in several different ways. Geologists divide or classify sedimentary rocks into four major categories based on their mode of origin, based on how they form. Today, I will introduce you to these four categories and some of the main types of sedimentary rocks, and I'll be using this geologic cross-section. You can see this cross-section is showing us just the very surface of the Earth. There are no tectonic boundaries, and that is because, again, these rocks form right at the surface of the Earth. The first classification of sedimentary rocks that we'll be looking at is a classification of rocks referred to as clastic sedimentary rocks. And clastic rocks are comprised of cemented together clasts. These are solid fragments or grains broken off pre-existing rock. So that's what a clastic sedimentary rock is. And there's actually a 5-step process, if you will, to the formation of a clastic sedimentary rock. As I mentioned, these rocks originate from a parent rock that has broken down into smaller pieces or clasts. So the first step in the process is that of weathering. And weathering is basically the initial process that starts to break up and corrode solid rock, and it can include both physical and chemical weathering processes. Eventually, the weathering sort of transforms a solid rock into sediment, into different pieces. Following the weathering is erosion. And erosion is the process that actually separates sediment from the substrate, right? It's removal of the surface material. Following erosion, there is transportation of this sediment. And transportation is essentially the carrying of sediment, the removal of sediment away from the parent material, and it is really a major component of grain evolution. So as sediment grains are carried further from the source area, they evolve. And specifically, these clasts, right, these broken pieces of parent material become smaller and smaller and smaller as they move further from the source area. And they become increasingly rounded, so they start out being quite angular. They become increasingly rounded and also more well sorted. So through the process of transportation, these clasts are becoming smaller, they are becoming rounded, and better sorted. Following transportation, at some point, sediments can settle out of the transporting medium. So this transporting medium, it might be streams, moving water, it might be wind, it might be ice, glacier activity, and at some point, these sediments are deposited. They are settled out of that transporting medium. So our fourth step in this process is deposition. And after sediment is deposited, it can, over time, undergo burial and eventually compaction and cementation, and transition from loose sediment to a solid sedimentary rock. And this final phase of compaction and cementation is referred to as lithification. Clasts and clastic rocks are really classified by their grain size, the angularity of the clasts, and the degree of sorting. And again, as clasts move away from the source area, they become increasingly smaller, rounder, and well sorted. Very coarse sedimentary rocks are rocks that generally form closer to the source area. So here in my cross-section, where my source area exists, right, the parent rock, once this rock starts to weather, right, we're going to form larger angular clasts, and these clasts are poorly sorted, and should they undergo burial and lithification, they will form a common type of clastic sedimentary rock known as a breccia. So a breccia is a common type of clastic sedimentary rock. It contains large angular clasts in a very poorly sorted matrix. If these clasts should be transported a little further away from the source, these clasts will become a little more rounded, this nature, and when the clasts are rounded and undergo lithification, this rock would become a common type of clastic sedimentary rock known as a conglomerate. And lots of students have heard of conglomerates. Conglomerates are a type of clastic sedimentary rock that have poorly sorted clasts, and the clasts themselves are primarily rounded, unlike a breccia, which has these angular clasts. As these clasts are transported further out and reach a coastal environment, an environment where our ocean meets the land, as I've drawn here, lots of sand is deposited in these areas, right? And sands are definitely much smaller and more well sorted than the clast and material in this area of my cross section. And this sand, as the sand undergoes burial and lithification, it can form a common type of sedimentary as abundant amount of quartz, which we refer to as actually a quartz sandstone, where you can have a lot of the mineral feldspar and form arkose. It's a different type of sandstone. But sandstones are plastic sedimentary rocks that form from the lithification of sand-sized particles. A little further out in our marine environment, you can see we're under the water here, we have finer particles that are transported out. And these finer particles are the size of silts and clay. And those silts and clay, just like the sand, right, once it's deposited, can undergo lithification and can form a very common type of plastic sedimentary rock known as shale. And we can also see rocks referred to as mudstones and siltstones in this area. But for simplicity, we're just going to look at the lithification of clay and the formation of shale. So breccia, conglomerates, sandstone, and shale represent four very common types of plastic sedimentary rocks. A little bit further out in our marine environment, we can have ions transported out in solution, and materials in our seawater are used to form shells of marine organisms. These are shells of marine organisms, and these shells, right, eventually, when these organisms die, these shells can settle to the bottom of the ocean floor. And they actually can settle to the bottom of the ocean floor by the billions, right? So we have these shells, and just like sediments, these shells can undergo burial. They can undergo burial and then become compacted and cemented together, and they can form a different classification of sedimentary rocks, one referred to as biochemical. So biochemical sedimentary rocks, they are not formed from clasts, but rather they are formed from the remains of once living marine organisms. And all these shells, after undergoing lithification, can form a common type of biochemical sedimentary rock known as a limestone. And there are many, many different types of limestones. That's because there are many different types of once living marine organisms, and also these limestones can have very different textures because the material that forms it can accumulate in different ways. So some limestones can originate from reefs. Those would be shells that grow in place, go out like snow. So lots of different types of limestones that comprise these very, very common biochemical sedimentary rocks. In some environments, organic material can accumulate and also undergo lithification. And what I'm referring to is organic material such as like wetlands. I'm going to draw a large wetland environment here. Okay, so here I have a wetland, and we have lots of organic material. And this organic material can not only include stuff from wetlands, but also just carbon-rich relics of different organisms and so forth. And oftentimes, I kind of lump this into wetlands because wetlands actually provide a very unique environment where this organic-rich material, it finds itself in an anoxic environment where it doesn't fully decompose. And what that really means is that the carbon in this organic material can start to undergo burial and can start to change, can start to cook, and we form peat, and eventually can form coal. And it's kind of odd to think of peat and coal actually as sedimentary rocks, but in fact we do classify them as a separate classification of sedimentary rocks because they form in a sedimentary type of environment. And this classification of sedimentary rocks is referred to as organic sedimentary rocks. And so for organic sedimentary rocks, it really just includes peat and coal and material that's coming from this really carbon-rich environment. We have one final classification of sedimentary rocks. I'm going to add that at the very far end of my cross-section. I know I'm kind of running out of room, but this is a very small classification in a very specific environment, and that's an environment where we have a lot of evaporation. And when we have a situation where we have evaporation like this, freshwater minerals can precipitate out of the freshwater, and those minerals can actually form unique types of sedimentary rocks. So here we see rock salt, and we can also see a type of sedimentary rock known as travertine. Sorry, you'll be able to see this in your textbook below there. That's travertine. And this classification of sedimentary rocks is referred to as chemical sedimentary rocks. So again, in summary, we have four classifications of sedimentary rocks: clastic, biochemical, organic, and chemical sedimentary rocks. And I've introduced just the very major types of rocks in these various classifications. So breccia, conglomerate, sandstone, and shale are plastic sedimentary rocks formed from broken pieces or clasts of a parent rock. Limestone comprises our most common biochemical rock. These are formed by once living marine organisms. Organic sedimentary rocks are formed just from that organic material that can accumulate and undergo lithification and form peat, which can eventually transition to coal and different grades of coal. And chemical sedimentary rocks form in an evaporate environment where we have minerals that precipitate out of solution. This is how we form rock salt and travertine. So each of the rocks that I've listed here represents a very different and unique sedimentary environment. So for example, we might have a terrestrial environment or a coastal environment in this area, a shallow marine environment, a deep marine environment, a wetland environment, or an evaporate environment. So these are just a few different types of sedimentary environments. You'll see in your textbook there are many others. There are mountain environments, and sand dunes, and lake environments, to name a few. So what I'm hoping you can recognize is that specific sedimentary rocks form in very specific settings, in very specific depositional settings or sedimentary environments, and subsequently they all tell a special story about the environment of where they formed. And during geologic time, the depositional setting of an area can actually change as the environment changes. And I want to show you quickly what I mean by that. Let's assume for a moment that our environment is going to change. And so I'm going to erase this part from our cross-section quickly to give us a little bit of room to illustrate a changing environment. And so for this example, why don't we consider our environment to change by increasing our sea level, right? And we know over geologic time, sea levels can change, they can rise, they can fall, and any number of things, many different things can cause sea levels to rise and fall. So let's just imagine in this instance, sea level is rising. So here we have our coastline at time 1. This is where our story starts. And in this story, we deposit sand that forms sandstone right at the coast. And then we deposit silty Well, in time 2, we're going to have our sea level rising. And when sea level rises, basically this shoreline migrates inland. And we call this process actually transgression. Now, we could have had sea level falling, right? Because that can happen as well, and that's a process known as regression, and you'll see that in your textbook. But in this story, let's have sea level rise, and at time 2, our sea level has moved up here in our cross section. So we have moved from this location up to this location. Sea level is rising, and I'm going to erase this sea level surface as to not confuse us. But what we've really done in this instance is we have changed our depositional settings, and now we have sand that is being deposited right at the coast, and that sand undergoes liquefaction and forms sandstone. And a little further out, we have silts and clays that deposit, and they form shale. And a little further out, we have shells that get deposited, and these shells eventually form limestone. So our sandstones, our shales, and our limestones, again, are a function of this new depositional environment. And over time 3, our sea level can rise yet again, changing our depositional environment. We can have sandstone with shale a little further out, and limestone a little further out. So although this is getting a little bit messy, and I apologize, I'm hoping that you can start to see a change in the rock types at one location. So let's imagine here that you are in a research vessel, and you're conducting some geologic research, and you lower down some drilling apparatus, and you take a core of rock from the bottom of the seafloor. That rock will actually comprise of we will be seeing is a sandstone, right? A sandstone, which is overlain by a shale, and that is overlain by a limestone. So we will have a core of rock, which represents a different sequence, and this sequence represents ultimately a changing environment in this location, specifically an environment that started out depositing sands, which was a coastal environment, that transitioned to an environment that was depositing silt and clay, perhaps a shallow marine environment, and that transitioned to a deeper marine environment. So we're in this one location, we have recorded this environmental change in our rock record. Thanks for watching today.